This is my work for part C and D, and so I looked at this and I said, well, I'm thinking maybe it's the same as up above, where there's something about the identity function. So when I substitute in an x value, I got to get the same value out as the y. So I decided to take a look at that same Desmos sketch that I created earlier, and I changed the function to a quadratic, and I didn't put a b term in there, or the middle term in there, because they weren't asking for that. And I graphed it, and lo and behold, sure enough, there are the two fixed points. When I substitute in 2, I get 2 for y, and when I substitute in -1, I get -1 back out. I was thinking maybe there's something about like the negative x, like the negative identity function, but those aren't the same, right? Because any point on there, the y changes sign. So that was a dead end. I didn't delete that line, but I left it in. So I know this, and I know. So then I wanted to figure out, how can I solve this algebraically? So x squared minus 2 has to equal the same x value that I substitute in. Now, we haven't done this yet, this term, but it's certainly something you did back in college algebra, or back in algebra 2 if you never taken college algebra. And this factors to x minus 2 times x plus 1. And when x equals 2, it's a 0. When x equals -1, it's a 0. So then we're going to check for those that the output's the same. And so remember, we're using this part of this function. So when x equals 2, 2 squared minus 1, well, let's see, 2 squared is, 2 squared minus 2. 2 squared is 4, minus 2 is 2, so that checks. If I substituted -1 squared minus 2, well, -1 squared is 1, minus 2 is -1, so that's checked. So those are the two fixed points in there. They are algebraically, we've shown this. But now they're asking me to find a function where x equals -2, and where x equals 3 are the fixed points. So what I did is I said, hey, I've got some coefficient of the x squared. I'm not worried about a middle term, and I've got some c constant, and that has to equal -2, because when I drop in, well, actually it has to equal some number, but knowing that it equals -2 helps me eliminate one of these variables. So that's going to get, if I substitute in -2 for x, that becomes squared, which is 4. So that gives me an equation: 4a plus c has to equal -2. And thinking about the same thing for when x equals +3, if I substitute 3 in for x, that gives me 9a plus c has to equal 3. And then what I'm seeing a system of linear equations, which you've done many times. I'm going to multiply the top equation by -1, and that gives me -4a minus c equals +2. Combine these, that gives me 5a equals 5. So a has to equal 1. If a equals 1, I can go back up here and say that 4 plus c has to equal -2. So c equals -6. And let's check that, make sure that does work in the second equation. If I substitute in, let's see, which one did I solve for? A. If I substitute 1 in for a for the second one, 9 times a plus c is not 3. Subtract 9 from both sides, c is also equal to -6 there. So I'm thinking 1x squared minus 6 has those fixed points of when x equals -2 and when x equals +3. So let's go look at my Desmos graph and see. So I used Desmos to graph that x squared minus 6, and lo and behold, there it works. And so it checks. One thing that I was just looking at is, while I was looking at this, maybe people aren't convinced that these are the points where all these graphs, all these composite functions intersect. I'm hoping I can convince you that it's, I mean, I could turn them off one by one and do that, but You can. I'll make sure I provide the link. Actually, I already have provided the link in the discussion forum to the sketch. You can go out to Desmos and play around it with it yourself. And you can't break it because it's saved in my account. Okay, so I hope that helps you with this problem. It was a nice exploration. Made me think.